So we've been looking at that Docker file in quite some detail. Hold on. Where are we? Okay. So this is all part of this procedure, which is to create the Docker images for the Nginx Plus, which is the commercial version, reverse proxy sample workload. 1. Download the following folder from the Nginx reverse proxy repo. 2. Find the app directory, which must be within that folder, and build an image from that directory. Docker build. 3. Build a custom image for Nginx Plus. Before you can build the image for Nginx Plus, you need to obtain the key named nginxrepo.key and the SSL certificate nginx-repo.crt. So you've got to go away and work out how to do that. You need the key and the certificate. Create a directory and store it in your nginxrepo.key and repo.crt files. Okay. Now in that directory, so you've created a directory, in that directory that you just created, you're going to create the following 2 files. 1, a sample Docker file, and we've been looking at that. Oh no. And the second file, so there's the Docker file. Secondly, an nginx.conf file, right? nginx.conf, modified from github.com/awslabs/ECS nginx reverse proxy /nginx. And you can see in the Docker file there is this line that refers to nginx.conf. So it says copy nginx.conf/etc/nginx/nginx.conf. So this line here has these two angle brackets pointing to the right, and they're saying append this to the thing that we find here, the 90 nginx file. Append this to the 90 nginx file. So append, lots of appending going on. So we want to append this verify peer to this thing, verify host, we want to append that. We want SSL cert to be added, SSL key to be appended. See, there's the 2 arrows. Here it says get text dash base. Get text base, next line curl, ampersand apt get remove, dash dash purge, dash dash auto remove, yes, ampersand rm dash rf. This is what the nginx.conf file will look like. Is this big? Quite big, not too big. So it starts with events and then worker connections 768. HTTP we put here, and then an opening curly bracket. Hash. Nginx will handle gzip compression of the responses from the app server. Gzip on. Gzip _ proxied. Any. Gzip types. Text / plain and application / JSON. So this is all about the gzip compression. Gzip min length 1000. Upstream backend. Opening brace. Zone. Name 10M semicolon. Server. App : 3000. Server. App2 : 3000. This has weight equals 1, this has weight equals 2. So what's going on here? I don't know. What's going on here? So we're configuring the back end somehow. And we have the word zone. So we somehow use zones with the back end. Server, listen, 8080, location, /API, API write equals on. Match, server OK, status 100-599. Server, listen, and then this is another server block, so we have all these blocks. So we have the match block, the server block, the server block up here. Listen 80, status zone. Hash, Nginx will reject anything not matching /API. Location, /API. So we're giving instructions to the server. This is this server block, and we're saying we're going to reject anything that doesn't match API. So we're selecting only things that are /API. Hash rejects requests with an unsupported HTTP method, and we've seen how we use this before. Okay, so we say if $, request method, request_method, ! tilde, and then I believe this is regex. So this carry means it must begin with either get or post or head or options or put, and it must end with that as well. So meaning it must be entirely one of those things and nothing more. Because this means this, the carry means this is what the beginning of the line must be like, and the $, means we want it at the end of the line, I believe. That's how it works. So if the request method is one of those methods, then return 405. Hash. Only requests matching the whitelist expectations will get sent to the application server. Proxy pass http / backend health check health_check URI equals /lorem -ipsum match equals server OK. Proxy HTTP version 1.1 ; proxy set header for the upgrade header, proxy set header for the connection header, proxy set header for the host header, proxy set header for the x-forwarded for header, proxy cache bypass $HTTP upgrade. For build an image from files in your new directory, docker build -t nginx plus reverse proxy. Let's understand this. So I'm reading documentation about using CloudWatch to monitor an nginx cluster, and there's a line which is docker build, there's a line which is docker build -t. What does the -t flag mean? As I think we know now, it's called, that kind of thing is called a flag. It's used to tag an image. So we're basically tagging the build with nginx plus reverse proxy, presumably then. So let's hold on. So I've just got the documentation in the HTML version. So where are we? So take a look at this nginx config file, nginx.conf file. So the structure, we have the events block, we call it the events block, events, and then opening brace, closing brace. And it's where we say worker connections 768. This block configures the Nginx worker processes. The worker connections directive, call it a directive. The worker connections directive sets the maximum number of simultaneous connections that can be handled by a worker process. So this is a maximum. 768 is a maximum. 768 is the maximum number of simultaneous connections that can be handled by a worker process. 2. We have the HTTP block. The main configurations for HTTP traffic are found here. We have this part that says gzip on, gzip proxied, gzip types, gzip minimum length. Here we're enabling gzip compression for responses to reduce the amount of data sent over the network. The gzip types directive specifies the MIME types that should be compressed, and gzip min length here defines the minimum size in bytes, so that's 1,000 bytes, for responses to be compressed. What's happening here? What do we mean upstream backend? Well, we're defining a group of backend servers that Nginx will forward requests to. Remember the idea of a reverse proxy? The server itself has a representative, not the client having a representative. The server has a representative. The server relies on colleagues to help it. Here there are two servers, app and app2, listening on port 3000. So here we have app and app2. Those are two names of servers. So these are the names of the servers which the Nginx server is going to go and consult. The wait parameter, wait equals 2, wait equals 1, the wait parameter determines the load balancing wait. App will receive twice the number of requests compared to app2. Okay, wait equals 2 compared to wait equals 1. App has wait equals 2, so app, as opposed to app2, will receive twice as many requests. Let's dig into that. What about zone name 10M? What does zone name 10M, let's put it in speech marks, zone name 10M mean? In the context of the upstream block, the line zone name 10M, so when we say upstream, we mean who are you relying on? Who are you going to? Remember this idea of a reverse proxy. Who are you're consulting other servers, but who are the other servers? Upstream. That's the word we use, upstream. The line zone name 10M is used to define a shared memory zone for storing session data related to load balancing. Here's a breakdown of the components. Zone. This directive creates a shared memory zone that can be used to store information such as the status of the servers in the upstream block. It allows Nginx to keep track of connections and load balancing state across worker processes. Name. This part specifies the name of the zone. In your configuration, it looks like it should have a specific name, but name is not a valid name here. You might want to give it a more meaningful identifier, such as my backend. So they're saying it shouldn't actually be zone name. You should actually replace the word name with something more specific. 10M. This indicates the size of the shared memory zone. In this case, it allocates 10 megabytes for the zone. This memory is used to store information about the backend servers, such as their status and waits. Okay? So that's what's going on with this block here. So the upstream backend, meaning, because Nginx is part of the backend, so that's why we have to say, well, what about the upstream backend? What about the servers behind Nginx? Well, we're going to have one server called app, another called app2. App will have weight 2, weight equals 1 for app. The server itself, let's see if we've had that explained. So we have two server blocks. Okay. So the first server block says server listen 8080 location /API API write equals on. This server block listens on port 8080. It defines an API, that's /API location, but uses an API directive that is typically used, so here I think that's the API directive. Okay, so we say but uses an API directive that is typically used in specific Nginx modules for handling API requests, like Nginx's Nginx-module-API. This may not be... Okay, so it defines an API location and it uses an API directive. Okay, so we're talking about these two lines. So when they say this may not be standard, we're talking about these two lines. This may not be standard and could depend on additional Nginx modules being compiled. Well, why does it say write equals on? Why does it say write equals on? What is that all about? The write equals on directive, which you see in the line API write equals 1. It's part of the Nginx API module. Okay, and the Nginx API module is used to enable certain capabilities for API requests. This setting enables the API endpoint to accept write operations. When set to on, it allows methods that modify data, such as post and put and delete. It allows those methods to be processed. So that's all achieved by saying write equals on. This means the server is allowed to handle requests that change the state of the application or the resources managed by it. In the context of your Nginx configuration, this line is likely meant to signal that the /API location should allow write operations. Without this directive, the API might only accept read operations, like get, and any write requests might be rejected. Using API write equals on is typically seen in configurations that require Nginx to serve as a reverse proxy for APIs that modify data. This directive is particularly relevant if you are using an Nginx module that provides API capabilities like the Nginx module API. So here's how it works in your configuration. Server block, listen on 8080, location /API. And then within braces, we say API write equals on. In this example, requests sent to API /API can modify data, assuming the appropriate methods, post, put, are being used. And there's an important note here. make sure you have the necessary Nginx modules installed and configured, as the API directive and its options may not be available in standard Nginx installations without additional modules. Of course, this is Nginx Plus. If you're unsure, check your Nginx installation documentation or your server's configuration to verify that the API capabilities are supported. So we have server, and we specify that value there. Match, server OK. What's going on there? So we have this matching block. This block defines a matching condition for server health checks, allowing for any HTTP status codes from 100 to 599 to be considered. Makes sense? What about this line? It says proxy pass and then HTTP : / backend. So I'm going to say, what about this line? So proxy _ pass. This directive tells Nginx to forward incoming requests to a specified backend server or group of servers. Is this just its regular role as a reverse proxy? I don't know. This directive tells Nginx to forward incoming requests to a specified backend server. This is proxy _ pass. It acts as a gateway, directing traffic from the Nginx server to another server that processes the requests. HTTP : / and then just backend. This part specifies the upstream server group, or the backend service to which the requests should be proxied. In your configuration, backend refers to the upstream block which was defined earlier. So you're allowed to do that. You're allowed to just put / backend, and it knows what's being talked about because you've named your upstream block backend. So we've got one part of the configuration file referring to another part. Yeah. So here, backend can resolve to one of the servers listed. That's how we say it. It can resolve to either the app server or the app2 server. They're the two names we used. So it can resolve to either of the servers listed, and Nginx will load balance requests between them based on the weights assigned. Weight = 2, weight = 1. When a client makes a request to the / API endpoint defined in the server block, location / API, proxy pass, HTTP : / backend, hash, forward the request to the upstream backend. Okay, remember, upstream means upstream basically means behind the Nginx server, the real server doing the work, the upstream server. Why are we using the word upstream though? Well, it's a metaphor. If you talk about a stream, it's a flow of water down the side of a hill under the influence of gravity. If you put some ink I don't know, some ink in the water upstream, it will flow downstream, won't it? It will affect everything downstream. Presumably, we're talking about a particular server being an upstream server because the thought is that if that server sends any message out, it affects all the servers. It affects all the other servers. It affects the Nginx server, which is like the man in the middle. Okay, if you think about it, it's all a matter of perspective. So we're assuming that messages are flowing from the server back to the client. This whole talk of upstream and downstream won't work if we reverse the direction and we talk about messages going from the client to the server. We're assuming, for the metaphor to work, that the server is higher up on the hill than the client. The client's at the bottom of the hill. About halfway up the hill you have the Nginx server. At the top of the hill you have the real server that Nginx is relying on to do the real work. So that's why we're calling it upstream. It's the talk of streams and upstream and downstream is just a helpful metaphor. It just gets used in IT a lot to talk about an object in a chain whose position in the chain is such that if you make a change to the object, it will affect all the other changes in the object, all the other objects in the chain. Yeah. So, yeah. So, incoming request. A request hits the Nginx server on the /API location, proxying the request. Nginx then uses that proxy pass directive to forward the request to one of the servers in the back-end upstream group. Load balancing. Depending on the load balancing configuration, in this case based on the weights, the request is sent to either app:3000 or app2:3000, returning a response. After the back-end server processes the request, it sends the response back to Nginx, which then forwards it to the original client. Some additional considerations. When using proxy_pass, you can set additional headers, and you can see that in your configuration. You can set additional headers to ensure that the back-end server receives relevant information about the original request. So examples of header names are host x forwarded for, handling protocols. The http:// prefix in proxy pass indicates that Nginx will use HTTP to communicate with the upstream servers. If your backend supports HTTPS, you would use https:// backend instead. This setup allows Nginx to efficiently manage incoming requests and distribute them to the appropriate backend servers, making it an effective reverse proxy solution for applications. So this is our file. Okay, get used to what it looks like. So it looks like with this match block, we've given it an identifier, server underscore OK, and we can reference that now. So here, there's a line that says health check, URI equals / lorem ipsum space match equals server OK. So we're saying match equals server underscore OK, which is what we typed out up here. So we're referring to this match block now. But why are we doing, what's this got to do with health checking? So what's a health check? Well, it's a check that usually a server is healthy. Is it okay? Can we give it traffic? In fact, let's just ask. So what are we doing? Are we saying that we've got a special URI that we use for a health check? So are we saying that we use a special URI to perform a health check? What is lorem ipsum? I believe it's just a Latin word that means this is a placeholder. So it's a general Latin word meaning fill it in with something. Why are we referring to match on this line? What does this have to do with health checks? And that should be okay. So certainly, let's break down this section of the Nginx configuration that you mentioned. So there's a line which says health underscore check, health check, URI equals / lorem ipsum. So we call this a directive, the health check directive. This directive is used to configure a health check for the backend servers in the Upstream block. It allows Nginx to periodically check the health of the servers to ensure they are responsive and can handle requests. URI equals / lorem ipsum. This specifies the URI that Nginx will request to perform the health check. In this case, it's set to / lorem ipsum. This URI should be an endpoint on your backend servers that responds with an appropriate status code to indicate health, e.g. a 200 OK response when the server is healthy. Match equals server OK. Well, this part refers to the matching condition, which you defined earlier in the configuration. I know, but why does it do that? The match directive specifies that any response status code from the backend in the range of 100 to 599 will be considered valid for health. Therefore, if the health check to / lorem ipsum does return a status code in this range, then the backend server is deemed healthy. What is lorem ipsum? In this context, it's just a placeholder URI used for the health check. Lorem ipsum is a common placeholder text used in the publishing and graphic design industries. But here it serves as a simple example to demonstrate the health check functionality. In practice, you would replace it with an actual endpoint that reflects the health status of your application, such as / health or / status. What's the purpose of health checks? Well, they help ensure that Nginx only forwards requests to back-end servers that are up and running. If a backend server fails to respond correctly to the health check, then Nginx will stop sending requests to that server until it becomes healthy again. But I don't understand. So is that match block specifically for health checks? What is being matched? What is going on? So the match block is a mechanism for defining criteria that can be used for various checks. In this case, it is specifically being utilised for health checks related to the backend servers. So underneath the line that says match, it says status 100-599. And that line specifies the range of status codes that will be considered valid when, for whatever context it is used. Here it defines that any response in that range is acceptable. We've said this is the endpoint that Nginx will call to check the health of the backend servers. URI equals this. And then we say match equals server OK. This specifies that the health check will use the conditions specified in the match server OK block. Therefore, when Nginx makes a request to lorem ipsum on the backend servers, it will consider the response valid if the status code falls within the range of 100 to 599. So that's what health is. It is nothing but a status code of 100 to 599. That's what we mean by healthy in this case. I asked what's being matched. In simple terms, when Nginx performs a health check by sending a request to the lorem ipsum uniform resource identifier, URI, it expects a response. If the response status code is between 100 and 599, then Nginx will consider the backend server healthy. If the response falls outside that range, or if there is no response, Nginx will consider that backend server unhealthy and will stop sending traffic to it until it becomes healthy again. Okay, that's fine, really. Right, let's move on. So we said build a custom image, what's called a custom image for Nginx Plus. Before you can build the image for Nginx Plus, you need to obtain the key named nginxrepo.key and the SSL certificate, which is nginxrepo.crt, for your Nginx Plus, which is licensed. Create a directory and store it in your nginx-repo.key and your nginx-repo.crt files. And then in the directory, create these two files, a sample Docker file and an nginx.conf file, and then build an image from files in your directory. So docker build -t meaning tag it with Nginx plus reverse proxy. 5. Upload your new images to an image repository for later use. Create the task definition to run Nginx Plus and the web server app in ECS. Next, you set up the task definition. This task definition enables the collection and export of Nginx Plus Prometheus metrics. The Nginx container tracks input from the app and exposes that data to port 8080 as set in nginx.conf. The Nginx Prometheus exporter container scrapes these metrics and posts them to port 9113 for use in CloudWatch. So let's be clear about what's happening here. The Nginx container, so we've got two. We've got two containers in play. You've got the Nginx container. It tracks the app, exposes it to port 8080. Then you've got a separate thing, which is the Nginx Prometheus exporter container. That takes the things that are being pushed out of port 8080 from the plain old Nginx container. No mention of Prometheus in that one, just Nginx container. It takes those, and then that does something to them, scrapes them, and then posts them out itself, this Nginx Prometheus container, to port 9113, and that's where CloudWatch comes and gets them. To set up the task definition for the Nginx sample ECS workload. 1. Create a task definition JSON file with the following content. Replace your customized Nginx Plus image with the image URI for your customized Nginx Plus image. And replace your web server app image with the image URI for your web server app image. So here we have a task definition. Container definitions, name, Nginx, image. As we said, this is where you'll put your customized. It's yours. You've customized it. Your customized Nginx Plus, which means proprietary image. Memory 256, CPU 256. I'm sure those should be in speech marks. Maybe I'm wrong. Essential, true. Maybe they're not strings. Port mappings, and then we have the opening square bracket for the port mappings and the closing square bracket. Container port 80, protocol transmission control protocol. Links, app2. Here's another object in braces, curly brackets, name app. Image, memory, CPU, essential, true. Here's another one. This time it's not name app, but name app2. App2. Image, memory, CPU, essential. Yeah, that's true. Here's another one. Name, Nginx Prometheus exporter. CPU 256, essential, true. And then we have this command key, -nginx.plus, -nginx.scrape URI. http://nginx:8080/API. Links, Nginx, because of course we have, the first one had a name of Nginx, so we have name of Nginx, name app, name app2, name Nginx Prometheus exporter, which likes to use that 9000 port, and you see port mappings 9113. Yeah. Register the task definition. Register task definition command. Create a service to run the task by entering the following command. AWS ECS create service. -- cluster, put in your cluster name. -- service name, put in the name of your service. -- task definition. -- desired count. Be sure not to change the service name. We will be running a CloudWatch agent service using a configuration that searches for tasks using the name patterns of the services that started them. For example, for the CloudWatch agent to find the task launched by this command, you can specify the value of SD service name pattern to be carry Nginx Plus service $. The next section provides more details. Because look, we said create service, that's the command, and the parameter that the command takes is service name, and that was Nginx Plus service. So that's not just that's really important. It's not just accidental, because we then have a regex pattern which looks for Nginx Plus service, which is the name. The carry just means it has to begin with that. The $$ means that the end of the thing we're looking for should be Nginx Plus service. So if we're saying the beginning of the term we're looking to match should be Nginx plus service, achieved by the carry, and the end of the term we're searching for must be Nginx plus service, that achieved by the US dollar, well, we're effectively saying it must just be Nginx plus service. And and we put that regex in this key called SD service name pattern. And here it is. So we're going to come to this shortly. SD service name pattern, and there we put that regex. Although here we don't have a US dollar at the end. We're saying it must begin with Nginx plus, Nginx dash plus, but then we put a dot, a period, and that means we can match any character, and then the star means 0 characters, so it could just be Nginx dash plus, or more characters, so in other words, it must begin with Nginx plus, but there can be anything after that, right? Dot star. So what have we done? We've had this big file with memory, CPU, the port mappings. We know we like to use port 8080 and 9113, that unlucky number 13. This is a definition file for the task definition. The task definition. You register it, you create a service to run it. Now we've got another task. We need to configure the CloudWatch agent to scrape the Nginx plus Prometheus metrics. The final step is to configure the CloudWatch agent to scrape the Nginx metrics. In this example, the CloudWatch agent discovers the task via the service name pattern. Remember, the tasks run on a service, so we actually use the name of the service to find the task. So it discovers the task, and it also relies on the fact that a particular port is being used, where the exporter exposes the Prometheus metrics for Nginx. With the task discovered and the metrics available, the CloudWatch agent begins posting the collected metrics to the log stream Nginx-Prometheus-exporter. To configure the CloudWatch agent to scrape the Nginx metrics, download the latest version of the necessary YAML file by doing this command with a URL in curl-0. Open the file with a text editor. So setting up an agent basically involves just doing curl. Open the file with a text editor and then find the full CloudWatch agent configuration in the value key, which is in the resource CW agent config SSM parameter section. Then in the ECS service discovery section, add the following service name list for tasks section. So put in this service name list for tasks. And we have these 4 keys: service discovery job name, the metrics path, the metrics ports, and the SD service name pattern. In the same file, add the following section in the metric declaration section to allow Nginx plus metrics. Be sure to follow the existing indentation pattern. So we want to add this. So look, these look like actual, I know we've got regex, but these look like actual metric names. How many connections are being accepted? That's something we can measure. That's a metric. How many connections are active? How many connections have been dropped? These are all aspects of our Nginx server that we want to monitor. Nginx plus, how many connections are just idle? How many Nginx plus HTTP requests do we have in total? Nginx plus SSL handshakes. Nginx plus SSL handshakes failed. Nginx plus up. Maybe that's just is it running. Nginx plus Upstream server health checks fails. We've got this dimensions key, and the value of the key is an array. And the array has just one element, and it is itself an array. There are 3 elements in the array: cluster name, task definition family, and the service name. So it's in this metric declaration key or section where we put information about the actual metrics and the dimensions for those metrics. As we know, dimensions are aspects that you can search for. Source labels job. Source labels job. We always have source labels and then label matcher. Source labels, label matcher. Label matcher, Nginx plus. More dimensions, cluster name, task definition family, service name, and then the word upstream in speech marks. Here there's not so many metric selectors. We only have the Nginx plus upstream server response time. So many metrics here. Here just one metric, response time. A third one, source label job, label matcher, Nginx plus, dimensions, cluster name, task definition family, service name, code. 2 metrics here, Nginx plus upstream server responses, Nginx server zone responses. 4. If you don't already have the CloudWatch agent deployed in this cluster, skip to step 8. If you already have the CloudWatch agent deployed in the Amazon ECS cluster by using CloudFormation, what you can do is create a change set. So notice the point of change sets. Here we've got a situation where we've already got a CloudWatch agent, so we've got a problem, which is what is it? We don't know what parts of our infrastructure have changed. So just try and think, what is the purpose of change sets? Why have AWS bothered to make change sets a thing? Anyway, we have this command, AWS CloudFormation create change set. -- stack name, CW agent Prometheus, and the name of the stack is pulling in the cluster name, pulling in the network mode, because we want that might change, so we keep it as flexible as we can. Capabilities, the capabilities parameter for our change set, and the region parameter, and the change set name. And it's got 4 parts: our change set name, Nginx plus scraping support. Five, open the CloudFormation console. 6, review the newly created change set, which is called Nginx plus scraping support. You should see one change applied to the CloudWatch agent config SSM parameter resource. Run the change set and restart the CloudWatch agent task by entering the following command: update service. So this is how we remember the CloudWatch agent is on ECS. It's a service. So there's no command which is like update the CloudWatch agent. It's nothing but a service. So we have to do ECS update service. Give the cluster name, $$ cluster name, desired count, because it's a service, 0, -- service, -- region. Wait about 10 seconds and then enter the following command. Again, update service. But this time it's desired count, the -- desired count parameter is 1. The service name is the same, the region is the same. 8, if you're installing the CloudWatch agent For the first time, enter the following command. This is not create change stack, but just create stack. And it's pretty much similar to before. We have this template body. The template body, well, we're going to point to a file for that, a YAML file. The parameters, -- capabilities, -- region. Viewing your Nginx Plus metrics and logs. You can now view the Nginx Plus metrics being collected. To view the metrics for your sample Nginx workload, open the CloudWatch console at console.aws.amazon.com. In the region where your cluster is running, choose Metrics in the left navigation pane. Find the Container Insights / Prometheus namespace to see the metrics. To see the CloudWatch logs events, choose Log Groups in the navigation pane. The events are in the log group, yada yada yada. Prometheus, which is in the log stream, and then the log stream within that log group is Nginx Plus Prometheus Exporter. It's called the Prometheus Exporter. And I think we'll end it there. Next time we'll read this tutorial for adding a new Prometheus scrape target, memcached on ECS.